Okay, so this screencast is all about geometric sequences in series, and a sequence is geometric if the ratio of any two consecutive terms is the same. So if I take the second term divided by the first and I get some number r, and then I take the third term divided by the second, get the same number r, and so on, then we have a geometric sequence. And that ratio r is called the common ratio. So, for example, find the first four terms of the geometric sequence with first term 3 and common ratio 2. Here we go. First term is 3. The common ratio is 2, so to get the next term I multiply 3 by 2 and I get 6. Then I multiply 6 by 2 and I get 12. And then I multiply 12 by 2 and I get 24. And I can get as many terms as I want just by multiplying each term by the common ratio. Now you can also have geometric sequences defined with formulas. So let's take a look at this one. A sub 1 is going to be 3 times 4 to the first, which is 12. A sub 2 is going to be 3 times 4 squared, which is 3 times 16, which is 48. A sub 3 is going to be 3 times 4 cubed, which is 3 times 64, which is 192. And the fourth term is 3 times 4 to the fourth, which is 3 times 256, which is 768. Now your common ratio could also be negative. So look what happens when we have a negative r. A sub 1 is negative 1/3 to the first, which is negative 1/3. A sub 2 is negative 1/3 squared, which is positive 1/9 because it's being raised to an even power. A sub 3 is negative 1/3 cubed, which is negative 1/27. And finally, a sub 4 is negative 1/3 to the fourth, which is positive 1/81. So if r is negative, you have alternating terms. Negative, positive, negative, positive. Okay, so now it's time for us to get the general formula for the nth term of a geometric sequence. And the nth term of a geometric sequence is this little formula right here. It's the first term times the common ratio raised to the n minus 1 power. So you need two things to do this. You need the first term and you need the common ratio. So here's an example. Find the 15th term, so there's n, of the geometric sequence whose first term is 20, there's a sub 1, and whose common ratio is 1.05. So a sub 15 will equal the first term times 1.05 raised to the n minus 1. So that's going to be 20 times 1.05 to the 14th. And let's get our calculator up to evaluate that. 20 parentheses 1.05 raised to the 14th. And there it is. It's 39.5986 blah 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 blah. Okay, so it gets you're going to probably use a calculator on a lot of these problems because you're going to be raising things to big powers. Okay, let's look at the next one. What happens if we don't know the first term? Well, we have to do a little bit of algebra to figure it out. So what we're given here is a sub 4 is 125 and a sub 10 is 125 over 64. And we're supposed to find the 14th term. All right. Well, 125 is going to equal the first term times r to the n minus 1. That means it's going to be r cubed, 4 minus 1. And over here, this is the 10th term. So that's going to equal the first term times r raised to the 10 minus 1, which is 9. Let's go over here and solve this for a sub 1. And now I will take this and I will plug it in right there for that a sub 1. So this becomes 125 over 64 equals 125 over r cubed times r to the 9th. So 125 over 64 equals 125 r to the 6th. And if I divide by 125, I get 1 over 64 equals r to the 6th. So r is the 6th root of 1 over 64. And that equals 1/2. The 6th root of 1 is 1, and the 6th root of 64 is 2. Okay, so we did all that work to figure out r. Now we can use that to find a sub 1. 125 over 1/2 cubed equals a sub 1. So that's 125 over 1/8, which is 125 times the reciprocal of 1/8, and we get 1,000. Now we have everything we need to find the 14th term. Okay, so a sub 14 is the first term times r raised to the 14 minus 1. So that's going to be 1,000 over 2 to the 13th, which works out to 1,000 over 8,192, which, believe it or not, reduces to 125 over 1,024. So what happens if I have a geometric sequence and I'd like to add all the terms together? Well, we have a handy formula that does that for us. It's this one right here. The sum of n terms in a geometric series is the first term times 1 minus r to the n over 1 minus r. So to use this formula, I need to know what the first term is, I need to know how many terms I'm adding up, and I need to know the common ratio. So let's find the sum here. Well, I'm going from 1 to 12, so I know that n is 12. And my first term, let's plug in 1 for I. So my first term is going to be 4 times 0.3, 1 minus 1. So the first term is 4. And my common ratio is 0.3. So the sum of the first 12 terms of this geometric series is 4 times 1 minus 0.3 to the 12th over 1 minus 0.3. And we probably are going to have to use our calculator to do this. So I'm going to do 4 parentheses. Let's get a fraction in there. And I'm going to do 1 minus 0.3 raised to the 12th. Arrow down to the denominator. 1 minus 0.3. Arrow out to close my parentheses. And we get 5.71428, blah, 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 blah. So let me drag that over here. Okay, so there it is. And sometimes, not always, but sometimes you can convert that to a fraction. Let's see if it'll work here. Nope, doesn't like to do that. Okay, so we'll just leave it in decimal form. All right, now, this is important. Make sure that your formula is in the form of a sub 1 times r raised to the I minus 1 power. I minus 1. If it's not, you need to write out the first term to get a sub 1. So notice that this is not I minus 1. So a sub 1 is 2 times 0.6 to the first. Okay? So our first term is 1.2. Okay, our r is 0.6 and n is 15. So the sum of the first 15 terms is going to be the first term times 1 minus 0.6 to the 15th over 1 minus 0.6. And if you work that out, in the interest of time, I'm going to go ahead and skip to the answer. That's going to be 2.998589. Work it out in your own calculator and see if your answer matches mine. Now here's something that's kind of cool. We can actually find the sum of an infinite geometric series. We can figure out how big the sum would be if I added up an infinite number of terms of a geometric series. But something important has to be true before we can do that. The absolute value of our common ratio must be less than 1. Okay, if it's not less than 1, we can't find the sum. Okay, let's do an example. Oh, I haven't told you the formula yet. The formula is right here. The first term over 1 minus r. So it's even simpler than the sum of a finite geometric series. The sum of an infinite geometric series is the first term over 1 minus the common ratio. So here's an example. What is the sum of this infinite geometric series? Let's get our first term, and it ends up being 3. So the sum of this infinite geometric series is the first term over 1 minus 1/2. And that works out to 3 over 1/2, which is 3 times the reciprocal of 1/2, which is 6. So what we're saying is, if I could add up 3 plus 3/2 plus 3/4 plus 3/8 plus 3/16 all the way out till I added up an infinite number of terms, it would all equal exactly 6.